In this video, we're going to conduct a one population z-test. We have already identified in the previous video that the problem given is in fact a problem that can be solved using the one population z-test. So now we will conduct one population z-test following the steps of hypothesis testing. So let us go to step 1 first, which is identifying our null and alternative hypothesis. So, since we have already talked about this before, pause the video and try to state rather what is the null and alternative hypothesis for the given problem. So, let us recall. So, let us see if your null and alternative hypothesis are correct. If you would remember, the null hypothesis is usually stated as an equality, and the alternative hypothesis is usually as an inequality. More often, the alternative hypothesis is also the claim, but sometimes there are also claims of equality that it can be the null hypothesis as well. So, let's take a look at our problem. A researcher claims, so that's our cue, that the average cost of men's athletic shoes, average, so most probably we're talking about the mean, is less than $80. Less than $80. So here, the claim is that the average, that I will already put mean, the claim, oops, I forgot about that. The claim is that the mean is less than $80. Now, how come I did not use median or mode? Because as you would recall, one population z-test only measures either the mean or the proportion. There are two cases for the mean, one case for the proportion. There is no case for the one population z-test that we will use median or mode. So therefore, we will not use median or mode. So now, the claim is that it's an inequality. Therefore, this should be part of our alternative hypothesis. Hence, our null hypothesis would be our mean is 80 or equal to 80, while the alternative hypothesis is the mean is less than 80. Further, since this is stating the null and alternative hypothesis, we should also state the direction. If you would recall, if it's just not equal to, this is a two-tail test. If it's less than, then this is a one-tail, lower tail test. And if it's greater than, it's actually a one-tail, upper tail test. And since this is less than, our hypothesis test is a one-tail, lower tail test, which will matter later on when we do our computation. So this is step 1. So now let us go to steps 2 and 3, which are the computation steps. And to do steps 2 and 3, we would need now to go to, or to use rather, Excel. So, to use Excel for this computation, again, we go to Data ribbon, which is already open here, and then we go to Data Analysis. And we shall select z-test 2 sample for means. Now, you might be thinking, sir, why z-test 2 sample? But this is a one population z-test. Excel does not have an exact data analysis tool for one population z-test, but we're going to use its 2 population z-test to do the computation for us. So, we will choose this. So once we click OK, we will get this. Now, you will notice something. Here, we have to input 2 variables, but as you've seen, the variable that's given to us or is encoded for us is just 1 because it's just one population. So what do we do? Let's cancel this first. Let's remove this first. And we need to encode another variable which we will call a dummy variable. What is a dummy variable? A dummy variable is a variable that we will input so that the program can do the operation for us. But that variable doesn't really exist, or it's not really counted. So under the dummy variable, we will just put a 0. Well, this is our actual variable, the cost of men's athletic shoes. So now that we have our second variable as the dummy variable, we will now go again to data analysis and select z-test2 sample for means. So here you go. Variable 1 is our original variable that is already here, which is already given to us. Next, our variable 2 is our dummy variable. Next, our hypothesized mean difference is this one, 80, so that's why we have to put 80. We're now looking for the variance of variable 1, which is actually this one. But remember that this is not variance, but standard deviation. So that would mean we would need to put the standard deviation here. So we need to put the square of 19.2. And you can calculate it in your calculator, or you can also use Excel. So our variance, which is the square of 19.2, is actually 368.64. For variance 2, this is just a dummy variable, so it should be something that would be very insignificant, something that will not affect our computation. So we shall put 0.0000001. Around 1, 2, 3, 4, 5 zeros will do. I have labels here, so I will check my labels. The alpha is here at 0.10, so I have to change this to 0.10. And the output range, I just want it here, down below. I think everything is okay, so we will now go click OK. And there we go. We have now a table that is computed for us to do steps 2 and 3. In the next video, we're going to do the interpretation of the results of our one population z-test.